So this is a review. You should have known how to calculate the molar masses of compounds. All you have to do, as you see here, is add up the number of atoms and, of course, multiply by their individual masses. Like this is from the periodic table for sodium, right here, 22.99. For carbon, of course, is 12.01, and for oxygen is 16. That's all you're doing. Now, this calculation is very important. You're going to use it now all the time, especially in this unit. So the molar mass is actually a conversion factor. The molar mass is a conversion factor. So let's look at here this question. It says, how many moles of glucose are in 5.380 grams of glucose? Now they're giving you the formula of glucose right here. Now, anytime you hear the word grams and you need to do conversions to moles and other units, right away, what you should be doing is calculating the molar mass. So we're going to do the molar mass of glucose. So C6H12O6. That would be 6 carbons plus 12 hydrogens and 6 oxygens. So 6 carbons from the periodic table, that would be 12.01 grams per mole. 12 hydrogens, that would be 12 times, we're going to look them up quickly. I know what it is, 1.01, but just to show you, 1.01. And of course, for oxygen, it's 16. And 6 times 16. So you add up all of these, you multiply and then add, you get a 180.18 grams per mole. Now, we need to understand how to use this. Whenever you say 180.18, you are simply using this as a conversion factor. So if you say 180.18 grams, well, that's 1 mole. And right away, you know that 1 mole is equal to what number again? Avogadro's number. Of course, it weighs heavier because sugar has, look how many carbon atoms and hydrogen atoms. So this can be rearranged. You could have mole on the top or grams on the top. Again, we're going to review or do another problem on dimensional analysis. There's a reason why we learned dimensional analysis in the first chapter. So let's look at the question. It says, how many moles of glucose are in 5.38 grams of glucose? Well, clearly the problem is giving me 5.380 grams of C6H12O6. And the problem is asking me to end with moles. That's what's needed of C6H12O6. So here's my conversion factor. If I'm starting with grams, what should go on the bottom? 180.18. We can put the C6H12O6 right here. I like to keep all the units. And then, of course, 1 mole is in the numerator. So all you're doing here is you're dividing. And again, the grams cancel out. So you're dividing this number, 5.380, by 180.18. Now again, sig figs, we go by what we started with. Which is 4 significant figures. So we should end with that number. So in this case, we have 5.380 divided by 180.18. And that gives us 0.29. Let me write down the number here. 0.029,859. Now we need to round this to 4 sig figs, so it's 1, 2, 3, 4. So what comes after this 5 is a 9, so this should be rounded up to a 6, so it would be 0.02986 moles. That would be your final answer right here. Now a quick way of doing this is anytime you have to go from grams to moles, just to keep this simple and show you the quick method, because we need to be able to do this calculation quickly. Anytime you have to go from grams to moles or mass to moles, you need to divide by the molar mass. MM stands for the molar mass. Now, what I need you to do is do the next one, still glucose. And of course, determine how would this now look like if you're going from moles to grams.